సబ్స్క్రైబ్ చేయండి. ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి.
Now we are going to discuss light dependent resistor. It is denoted as LDR, light dependent resistor, or photoconductive cell. Photoconductive cell. So in the name light dependent resistor is depends upon light. Resistance dependent upon light. Resistor works dependent upon light. That is the light dependent resistor, that is the LDR. It's named as also photoconductive cell. Photoconductive cell means photo means light, conduction cell. Okay, that means a light incidence on any metal, then electrons emitted. This is the photon means light incidence on the any metal, electrons are emitted. So if electrons emitted, that metal is converted into conductor. The same as the resistor means resistance depend upon light. Okay, the light incidence on any metal, that resistance is changing with light. Then the light incidence on any metal, conductivity is high, is increasing, resistance is decreasing. So in this session we discuss the principle of LDR, light dependent resistor, theory of LDR, construction and working of LDR, spectral response of CDS means cadmium sulfide. Okay, so what is the LDR? LDR means light dependent resistor. For example, we take this is the metal, the light incidence on this metal. Okay, then electrons are emitted. If electrons are emitted, then electricity easily flow. Then the metal is conductor. So if light is high, light means intensity of light is high, then conductivity is high, because intensity of light is increasing, then electrons are heavily emitted, then the conductivity is increasing. So intensity of light is increasing, then conductivity is increasing. Okay, at the same time this is the metal, the light incidence on the metal, electrons are emitted. If electrons are emitted, that is the conductivity is high. If conductivity is high, resistance is low. Thus the way, if the light incidence on the metal, so the intensity of light is increasing, the resistance is low. The intensity of light is increasing, the conductivity is increasing. At the same time, the intensity of increasing, the resistance is decreasing. This is the principle. Okay, the photoconductive cells are light dependent resistor earlier based on principle that electrical resistance of semiconductor material decreases. The electrical resistance is decreases when they light radiation. Light means photon radiation. So the conductive cell or light dependent resistor based on principle that electrical resistance of semiconductor material decreases when the exposure of light, that is the radiation. The rapid decreases in the resistance depends on the intensity of color of light. So that means resistance depends upon the intensity of light and also color of the incidence of light. That is the principle. What is the principle? Electrical resistance of semiconductor material is decreases when they exposed of light radiation. That means the rapid decreases in the resistance depends on the intensity of light or color of the incident light. This is the principle. Next, theory. When light falls on the material, so this is the iron plate. Then on the iron plate, the cadmium sulfide, that is the CDS, cadmium sulfide is deposited on the iron plate. On the surface, transparent metal film is the fixed. So this is the totally metal plate. First of all, iron plate. On the iron plate, cadmium sulfide is the deposit. On the surface, transparent metal film is the fixed. So first of all, the light incidence on the transparent film. The light incidence on the transparent film. Then the photoelectric effect. According to photoelectric effect, the light is incidence on the metal film. In the transparent film, the rays are. So then electrons are emitted. Electrons are emitted through the circuit. When the light incidence on this total iron plate, the electrons are emitted. That is the photoelectric effect. For each emitted electron, for example, one electron emitted. So for each emitted electron, this emitted electron, one hole is created. For each emitted electron, one hole is created. For example, just this is the CDS. So this is the metal, free electrons. So first of all, light is incidence on this plate. So for next, electron is emitted. So this electron, so this is the circuit. This is the electron. For each emitted electron, one hole is created. one hole is created in the material. This electron hole pair, this is the emitted, this is the hole. This electron pair is pre-moves to current carriers. So another electron is emitted, hole is created. Another electron is emitted, hole is created. So these pairs, hole and electron, hole and electron, hole and electron, positive and negative, positive and negative, positive and negative. Then the current carriers is easily current carrying, because one pair, hole positive and negative, positive and negative, positive and negative. Okay, so easily current carriers. Then conductivity is the increasing. Conductivity means the allow the current flowing. So conductivity is the increases. So the electrical resistance decreases. Electrical resistance means oppose the current flowing. Conductivity means freely allow the current. So this is the freely allow the current, this is the oppose the current. So one electron is emitted, then hole is created. Another electron is emitted, then hole is created. So these pairs, hole and electron, hole and electron, hole and electron, easily freely allow the current carrier. So this is the conductivity is increasing, resistance is decreasing. Okay, so hence it is called light dependent resistor, also called photoconductivity cell. Light dependent resistor, photoconductivity cell. In this experiment, the thin film cadmium sulfide, this is the cadmium sulfide CDS. Then thin film cadmium sulfide is deposited on the one side of iron plate and placed below a transparent foil of the metal. When light radiations of sufficient energy fall on transparent film, so then the layer CDS is reduced. The resistance of CDS is reduced when conduction is increased. Because one electron emitted and a hole created, then the pair allow the current carriers. Though conductivity is increasing, resistance is decreasing. So current starts flowing the battery circuit connected between iron plate and transparent foil. This external battery is included in the circuit, generate the direction and provide path the current flowing. Voltage varying from few volts to several hundred volts. Voltage is changes with few volts from several volts is applied dependent upon photo cell. Characteristics of LDR. Characteristics means graph, the graph relation between illumination and the resistance. Illumination means intensity of light. Illumination means the units of intensity of light. First of all, this is the 0, x y direction, lux illumination 20. So on the x axis illumination and the y axis resistance means ohms, kilo ohms, 100 kilo ohms. So here the characteristics means the graph, the relation between illumination and resistance. On the x-axis illumination, the y-axis resistance. This is the value of, this is the curve. This is the curve. High resistance is the 100 kilo ohms. 100 kilo ohms. So he is known as a dark resistance. Dark resistance. So the graph depicts relation between illumination and resistance. It may note that when not illuminated, so at this time not illuminated, the resistance is very high. The resistance is very high. The high resistance is called as dark resistance. The range of dark resistance is 100 kilo ohms. This is the dark resistance at the range of illuminated, not illuminated. Not illuminated means dark, in darkness. Not illuminated means not intensity. There is no light. Is dark at dark resistance. And illuminated with strong light. The cell resistance falls. The resistance is low. The resistance is 0. Here the resistance is 0. Here the resistance is very high at not illuminated, not light. The light is very strong here. The light is strong is very here. So the resistance is 0. Resistance is increasing with light weakness. The resistance is decreasing with intensity high. Intensity strong. The resistance is decreasing with intensity is strong. Okay, the resistance is increasing with light weakness. This is the characteristics of LDR. Okay, the characteristics of LDR shows the relation between illumination and resistance. Then the spectral response of CDS, that is CDS means cadmium sulfide. The spectral lines are here. The spectral lines are produced. It is closely matching the response of the human eye. Because like that the human eye, the response is very sensitive to visible light. These are all here spectral lines are produced. The spectral lines, the relative sensitivity. This is the wavelength. Of light. This is the relative sensitivity. The spectral lines, the spectral response is the curve of this type. So it is closely, the spectral response of CDS, it is closely matching the response of human eye, like the human eye, because that the response is very sensitive. The response is very sensitive to visible light. It is the best over the visible spectrum. And tapers up towards the ultraviolet and infrared. So this is the best over the visible spectrum. Applications of LDR. LDR circuits are used in light meters. LDRs are used in light meters. LDR used in to work as on-off switch. LDR used in to work as a on-off switch. LDR used in street light control. LDR used in relay control. LDR used as a voltage regulator. Because here conductivity changes. So the LDR as a voltage regulator, the LDR used in burglar alarm. These are all applications. LDR used in light meters, LDR used as to work as on off switch, LDR used in street light control, LDR used in relay control, LDR used as voltage regulator, LDR used in burglar alarm. Advantages of LDR. LDR is the high sensitivity. LDR is a high sensitivity. LDR is low cost and long life. Low cost and long life. LDR is high dissipation capability. High dissipation capability. Okay. LDR is high voltage capability. High voltage capability. Because so LDR used as a voltage regulator. Advantages of LDR. LDR is high sensitivity. LDR low cost and long life. LDR is a high dissipation capability. LDR is high voltage capability. Disadvantages of LDR. The current changes with change in light intensity. The current main disadvantage is the current change with intensity of light. Intensity of light, and also relatively narrow spectral lines. Narrow spectral response, because it is closely matching the response of human eye. So its main disadvantage is the narrow spectral response.